All right, so we're continuing on with powers and exponents. This time, this is a little different. There's no review here. What we're dealing with is rational exponents. Rational refers to a fraction. And so examples of that is you could have like something like 8 to the power of 2/3 or 27 to the power of 4/3. And so what you're looking at is totally different, because before, when we did those 6 power rules, we had a lot of different scenarios. We had negative exponents, we had bases with fractions that were negative, but we never had exponents that were fractions. So that's where we're headed here. Now, so we have an example here like x to the power of a divided by b. That is what we call exponential form. And it's exponential form because you have an exponent. All right, and it's written as a power. And so what we can do, there's 2 formulas here where we can convert it to what's called radical form. All right, and so we have something like this. Now, radical refers to something like a square root sign, only we're not going to do square roots. We're going to do something a little different. And what happens is our base goes under the root sign, and our top number here, or sorry, our denominator goes right here. And then the whole thing is taken to the power of our numerator. All right, now, that is the most used form. There is another form, but you'll probably see this maybe 5% of the time. And again, it's in radical form. It's the same look. Again, our base is in under the root sign. Our b is still here, and I'm going to explain what that means. All right, but this power to a, it's inside the root sign. All right, so those are our 2 different formulas that we're going to use. Probably, like I said, the first one is what you're going to see most of the time. Now, for an example here, how would that work? 8 to the power of 2/3. All right, and so here's what I'm going to do. Again, my base goes under, I'm going to draw a root sign. Notice how I said root sign, not square root. All right, so my base goes underneath here. All right, the denominator goes right in here. So there's my little 3 in here, and then I am squaring it. Okay, so now inside here, what I'm looking for is the third root of 8. You have always found the square root of 8. Now we need to find the third root of 8. And what the square root of 8 was, what number times itself would give you 8? But we're not finding that, right? Like if you have the square root of 25, there is an assumption there that there is a little 2 in there, where you're looking for what number times itself twice will give you 25. Well, now we're looking for the third root of 8, which means what number times itself 3 times will give you 8? And the answer to that question is a 2. Because 2 times 2 times 2 will give you 8. And again, I have this little 2 here, which of course, 2 squared, 2 times 2 is 4. Now, there is some numbers that you won't be able to do in your head. And so you got to be able to use your calculator. And there's a symbol. There's a couple of them. One will be something that looks like that on your calculator. So you have a y underneath a root sign with a little x there. That is one example. The other example is you might get y and 1 over to the x. That might be another button that you will have. But again, that's something you're going to have to figure out with your calculator. Try finding the third root of 8 and see if you get 2 using your calculator. All right, so there we go. Now, a couple of examples. I'm going to erase this, but we are, I'm going to erase this for a little bit of it anyways. All right, so examples of how are we going to find my rational exponents. So I'm going to erase, just leave our formula there for now. All right, so first example, I have, whoa, that's so wet. I'll ruin my markers. All right, so here we go. I have 81 to the 1/4. All right, now, again, it's in an exponential form. I'm going to flip it here to radical form using my formula, I guess, if you will. All right, so there's my root sign. The base goes underneath. The denominator goes right in here. And then to the power of 1. But anything to the power of 1 is just itself. So I'm going to leave that. So now what I'm looking for, and again, you've got to be able to figure out how to use your calculator, or a lot of times I'm just going to use numbers that are easy calculable. I want the 4th root of 81. I'm looking for the number that multiplied by itself 4 times will give me 81. And so that number, again, you could use your calculator, is going to be 3. Because 3 times 3 is 9, times 3 again is 27, times 3 again is 81. But again, if you have trouble with that, you got to learn how to use your calculator and find those buttons to be able to do it. All right, B. What do we got here? Negative 64 to the 1/3. All right. So now I have a negative number for a base. But again, I'm going to put it into radical form. And so I got a negative 64 there. And the denominator goes there. But again, I'm going to the power of 1. So I'm not going to put that in there because, again, anything to the power of 1 gives you itself. Now I'm looking for what number times itself 3 times will give me negative 64. Now, this is a little bit different because we've always had a negative number under here for a square root, which is not possible. But when we get into the 3rd root, it is possible. And the 5th, and the 7th, and the 9th, and the 11th, and the 13th. If it's an odd number, it's doable. And there is a number that if I multiply it by itself 3 times will give me negative 64. And in fact, that number is negative 4. Because negative 4 times negative 4 is negative 16, or sorry, is positive 16, but times another negative 4 gives us that negative 64. Hence why the odd numbers, it's okay to have a negative in there. But again, if there's a negative sign underneath the root sign, and this is a 2, 4, 6, 8, 10, even numbers, it isn't doable. All right, C. We have something, here we go. 25 to the power of 3/2. All right, so again, that's an exponential form because I got an exponent there, and base as written as a power, but I'm going to convert it to, again, a radical form. So again, make sure I get things in the right spot. My base goes underneath. All right, my denominator goes here. And now I do have an exponent in the numerator that is not a 1, so I do have to take it to the power of 3. All right, so I'm looking for the 2nd root of 25, which is a nice way of saying the square root. Although we never usually put the little 2 there, but it should be there. All right, and so, well, the 2nd root, or the square root of 25, what number times itself twice will give you 25? That is a 5. And again, we have to the power of 3. So now I have to deal with the numerator, right? This power, 5 to the power of 3, 5 times 5 times 5. That gives me 125. All right, a few more here. D, 16 to the 3/4, to the power of 3/4. All right, so once again, I'm going to put this in radical form. My base goes underneath. All right, my denominator goes in here. And again, because my numerator on that exponent is not a 1, so I'm going to put it in there. All right, so now before I take it to the power of 3, I have to find the 4th root of 16. So some number times itself 4 times will give me 16. That number is a 2. Because 2 times 2 times 2 times 2, 4 times, will give you 16. But then I have to take 2 to the power of 3. 2 times 2 times 2 will give me an 8. All right, so now we're going to try ones where some of our power rules again are going to come into play. All right, so let's see here. Did I get the room? All right, so next up, there we go, nice and dry. E, we have 27 to the negative 2/3. All right, now, negative exponent. We just did this last class. I have to deal with that negative exponent first before I put this in radical form. All right, but again, when we're dealing with a negative exponent, we're going to flip the base. So it's going to be 1 over 27. And change the exponent to a positive. All right, so now we just use the negative exponent power rule. Now look what I got. I have two pieces inside the brackets as my base, and I have an exponent. So now I'm going to use the expanded power rule, where I'm going to apply that exponent to both the numerator and the denominator. All right. So now here's what I'm going to do. I'm going to go over to the side here, and I'm going to figure out those two things separately. All right. Now, first off, I've got 1 to the 2/3. So this is over on the side here, separately. Well, again, if I write that in radical form, again, I put my 1 under here, 3 goes in there, and then I have to square it. Now, I take the third root of 1. What number times itself 3 times gives you 1? 1. 1 times 1 times 1. And then I square it. 1. Now, here's a little hint for you, because I'm not going to do this again. 1 to the power of anything is 1. Easy. Should be a power rule, but it's not. All right, now, I go over and do my denominator here, where I have 27 to the 2/3. All right, and again, I'm going to write it in radical form. So I got my 27 here. I'm taking the third root of it, and then my numerator here is squared. So I have to find the third root of 27 and then square it. And so again, the third root of 27 is what number times itself 3 times equals 27. And that answer is 3. Then I square that 3. I get a 9. And so that is my denominator. And so my final answer in rational form, which I'm going to ask you to do, now just type these into your calculator, is 1/9. All right, so you get 27 to the negative 2/3. We get 1/9. All right, let's try something else like that. Let's see here, F. All right, I have 64 to the negative 2/3. All right, so once again, I have a negative exponent. So I'm going to use my negative exponent rule first, where I flip my base. All right, and change my exponent to a positive. So there's my negative exponent rule. Now I'm going to use my expanded power rule, where I apply my exponent to both the numerator and the denominator. Now, as I said just a couple of minutes ago, 1 to the power of anything, just 1. But I got to figure out 64 to the 2/3 here, so I can figure out my denominator. So once again, I'm going to take that 64 to the 2/3. I'm going to write it in radical form. So there's my 64 in there. We're going to need the third root of that 64, and then my numerator here is squared. All right, so again, the third root of 64, what number times itself 3 times gives you 64? Again, you're going to have to learn to use your calculator as we move on in this unit, but that number would be a 4. 4 times 4, 16, times another 4 gives you your 64. And then I square it, I get 16. And so my denominator here is 16. And so my final answer is 1/16. All right, now step it up even further here. All right, so let's see here. All right, so let's see here. We got next up G. Kitchen sink time here. So we got 16 over 25 to the power of -3/2. There we go. So we got everything going on here. We have a fraction for a base, fraction for an exponent, and it happens to be negative. Just about everything we can have going on here. But again, this is going to deal with my negative exponent first. I'm going to flip the base, change my exponent to a positive. So instead of 16 over 25, I've got 25 over 16. Change my exponent to a positive. All right, there's the negative part of the exponent taken care of. Now, again, I'm going to use the expanded power rule. I'm going to apply that exponent both my numerator and my denominator. All right, now I'm going to go and do these separately. All right, so the numerator here first. I have 25 to the 3/2. I put that in radical form. The second root of 25, also known as the square root, 5. To the power of 3, 5 times 5 times 5, we get a 125. So there is my numerator. All right, I go now and figure out my denominator. So I got 16 to the 3/2. Same idea, I'm going to put it into radical form. All right, and so again, I'm looking for the second root of 16 or the square root of 16, and then I got to cube it after. Well, the square root of 16 is a 4. All right, and then I cube it. 4 times 4 is 16 times another 4 gives me 64. And so my final answer here is 125 over 64. That is my exact value. All right, last one. We'll do one just like that here. H, where I'm looking at 27 over 8 to the power of -2 over 3. All right, so again, we got everything going on here. Fraction for base, rational exponent, negative exponent also. And so I'm going to deal with that negative exponent by, again, flipping my base and changing my exponent to a positive. All right, once again, I'm going to use my expanded power rule. So I'm going to apply that exponent to both the numerator and the denominator. All right, so now I got to figure out two different questions in one here, right? And so I got 8 to the 2/3. I'm going to put that in radical form. All right, so I'm looking for the third root of 8. We've already had that one. What number times itself 3 times will give you 8? That is a 2. And then we square it, which gives me a 4. And so my numerator is 4. All right, and then lastly, doing the denominator. So I got 27 to the 2/3. I put that in radical form. So there it is. So I need the third root of 27. Then I got to square that. Well, the third root of 27, what number times itself will give you 27, or times itself 3 times, I should say, will give you 27. Well, that would be a 3. 3 times 3 is 9, times 3 again is 27. I have to square it. That gives me my 9. And there is my denominator now, which is in rational form, as I think your textbook calls it, 4/9. All right, so that is rational exponents. But again, when we're dealing with power rules,